So while we are on live, let's wait for the others. At least we have 5 in the group list. Someone should volunteer and share the link on your platform to enable people out there to join, um, so that at least we can just continue, because we don't have much time to spend. We just have a few moments, like 30 minutes or so. And also, if you can hear me very, very well, please drop a comment. Let me at least know that yes, I'm with you out there, please. So, are we together, please? Let's have a message dropped on our comment section. So, thank you very much, Hibbat. We are together. Someone is just saying hi. So there is no cause of an alarm. You can see my at least see my audio visual. My video is coming out. We can say it's not perfect, but at least we can be able to achieve something. So on a quicker note, you're all welcome to this live session on the relational algebra, entity relationship model, and database normalization. This is what we are going to look at in a snappy way. We try to at least have a video of the session in both the linear algebra, the ERM, and the database normalization. So we are going to see some key functions in these three key areas of database management system, which we are going to start in with linear algebra. We know that linear algebra is here to in order to assist database administrators and designers in querying out the system. That is how well are you going to use your linear algebra to pull out information from the system. And we have uh, 5 to 6 basic characteristics or the features in which you are going to use in linear algebra to perform operation. And one of it, we have a selection of a tuple, we have a selection of a column, or selection of an attribute. We need to iron these things out. If we say attribute here, we are talking about the rows, while if we say tuple, sorry, we are talking about the rows. Whereas if you say attribute, we are talking about the column. So don't be too confused if you see selection of a tuple or selection of a row and then selection of a column and selection of an attribute. So in selection of a tuple, here we have a syntax already given to you, and I believe you all understood the syntax, which is usually using a sigma notation. A sigma notation is used to select a tuple in linear algebra. So probably the exercise is giving us, I want to use xyz or wxyz as an instance in regard to the earlier example given as ABCD. So we have, let's assume we have W, we have X, we have Y, and we have Z. So this is our tuple. We have them as these as our tuples now. The rows is our tuples. The columns is our attribute. So here we have a features. This is giving us relation R. Is giving us relation R. And here, for instance, we have A, we have B, we have, and again, sorry, let's say A, B, B. So we also have as A, B, A, B under X column. Under Y column, let's assume we have 2, we have 3, we have 7, and we have 20. And other X, let's assume we have A, and then we have sorry, let's use numbers, please. Let's use the numbers that is given there: 7, 7, and then 3, 10. So if a relation is given as, you should find a selection of a tuple. We use a sigma notation called, this is my sigma notation now. It's asking you to carry it out an operation of A is equals to B, where and D is greater than 5. Let's assume this is given in respect to R. So in respect to R. So this operation is given, let me have an overview of what we are doing, maybe probably. So this is what we have now. So you were asked to find the selection of this. So first of all, sorry, not A and B, is going to be X, W and X, please. W and then X, where our Z, I want to change it. So where our Z is greater than 5. So we have two operations here. First operation is X equals to Y. So you should go through this and check where your tuples of W is equals to X. So this is the first operation you are embarking on. So here you are going to still have your W, your X, your Y, and then your Z. So here, which operation now is equal? You see A of W is equals to A of X. So you have A, 2, and 7. So here, are they equal? They are not equal. So totally we are going out with this. Here again, they are not equal. But here, B and B, that is W and X, are equal. So we are going with this and take this, take this. So we have B 2010. And then again, this is saying that where Z is greater than 5. So here, if you are selecting where Z is greater than 5, then you are okay. In this operation, this is where you are going to stop. But in case, if you were asked where Z is greater than 7, let's assume is greater than 7. So in this case, you are going to go forward to this and have your sigma equals to X and Z is greater than 7 is going to give you as W, X, Y, Z, as you're going to have only this. Then this one is going to be cancelled. So you have B 20 and 10. This is your final. So meanwhile, if you to find a tuple where Z is less than 7, it means you're returning nothing. Rather, you will just have XYZ, WXYZ, and that's all. You're returning no record in this very selection criteria of a tuple. And with this, I believe this is where it has cleared an air of what we had in the previous lesson. So we are going to look at how we are going to use selection of a column. In selection of a column, that is selection of an attribute. You remember in the interim of this class, we said columns are attributes, rows are tuples. So we are going to see this where we can be able to, let me use the same A B B of XYZ, and then let me have operation, and our column attribute or column selection is being represented by a capital pi. By a capital what? Pi. So we have pi, and we want to select a column where X and C, where X and C are equal, W and X are equal. So we have this of W, comma, X are what? Are equal. So this is what you are going to select in this very criteria. So what you are expected to do is a projection. The projection here, you are going to select only two columns now because they have given you only X and Y. So as only W and X, and you are going to have your projection as W, X, and that's all. A, 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 B, B, A, B, B. So this is what you are going to have at the end of the day. But it went further and asked you that if you have any duplicate, if you have any duplicate of having the same value of A, the same value of W, then they are not going to reflect in this very projection. That is why in the example given there, you have been seen as alpha, alpha, beta, beta is given as in the case where we are having 4 rows and ones are reflecting in both alphas. So they have taken away those. So the same thing in this case, if you are using the projection of this, you're going to have at the end of the day as W, X is going to be A, B, and then B, A. So this is should be your final answer. So whenever you take away the column that is expected of you to pick here, are we together? The column of you that is expected to pick here, then you now look at the common values between the given columns here. So again, if now here you were asked to have X, Z. So you see now, I'm trying to give you instance where you can have a duplicate. Though we cannot have duplicate, we can have if and only if we have A here. Let's assume we change this thing to A. So it means here we are going to have A, 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 and B. Going by Z, sorry, this should be Z. We have 7, we have 3 is 7 again, we have 3, we have 10. So here, if we are going by this projection, after having a given attribute to select, then we will go further and have W, Z as we pick 1 here and then drop 1. So we have A as 7, A as 3, B as 10. And this should be your final answer in the projection. So also going forward, we have what we call a Citation product. In Citation product, you are expected to multiply each attribute with its tuple with its own column. That is what is expected of you. A column attribute with a column. So that is why in the given example here, you have seen where we have AB, but I will change it in such a way we have V, we have W, we have X, we have Y, and we have Z. And this is going to what? We are going to spread this into 2. We have R relation or relation R is giving us only our what? V, and then W as A and B with attribute of 1 and 2. So that is our relation R. And we also have a relation S. And in relation that is relation S. So in Cartesian product, if you were asked to find a Cartesian product of a relation R with S, it means here you are expected to take each of these rows, each of these row like this, right? This is the top one. Column which return to be our attribute. So this is what we are going to do in this case. And to have this Cartesian product of R and S, we are going to have our full table of V is going to be little bit upward. Let's shift this. Let's shift this to V W as A, B, 1 and 2, right? So that we can have our V, W, X, Y, and Z here. So here, what we are saying, we are going to pick this. This is coming back to its normal place. This is also coming back to its normal place. Then we multiply through by what? By this. Are we together? So how are we going to do that? This is the question, right? So we are done with this relation. So now what left is the second relation here, and it's going to be B2. You still pick. You have your A, 5E. You take for the next one, you have your B2, sorry, this B5E. The next one is going to be B2, B10, B. The last one is going to be B2. Then you have C5B. With this, you are done with this very particular selection criteria. Unless otherwise, where they ask you again, after finding the selection criteria, after finding the Cartesian product, you should go forward and then find whether projections of a attribute or selection of a tuple. where you can be able to at least do something related to what we did in the earlier operation. So this is how you go about your selection criteria. So the next one is the union of two relations. Union of two relation. So in finding the union of two relation is just like the normal set union set you used to do in your statistics. So let's assume we have a relation R and S as given below, but this time around is going to be a uniform. Like for the R, we have it as X, Y, where we have A, and then B. Then under Y we have under this is going to be 1, 2, 1. Right? So under S tuple, now we are done with what? With R relation. Now the S relation is going to be given as A and then B, where our, sorry, this also should be X and Y. And A, B, we have 2 against and then 3 against B. So if this is given to you and they ask you to find the union of two, you were asked to find the union of R and S, right? This is the union, don't mind my union. So the union of R and S. So you're going to do something like what you're going to pick like a summation, but where you have a duplicate, you need to ignore one and go with the order. So our X and Y is going to be what? Now this is the only number. So we pick A and 1. We have this, and this is replicating here also. So we have our A with 2, right? So remain B. Now our B is going to be B with 1. There is no B with 1 here, so it's going to be B1. Then the last one, we have B3. B3 is not here, but it's here. So B3, just as our normal union of a set. So that is for this. And again, if we are asked to find a set difference, or let's just have intersection of these two relationship first, where you have intersection of R and S. So this is going to be like what is common in between these two relationship. So there is nothing to waste time here than just to give X, Y as only this one that is in this set and is in this relation. This relation and this relation has A2 as a common attribute and a tuples here. So we have A2, and this is for this. You don't have any issue regarding this very one. So again, another component of this relational algebra in database management system is a set difference. So if a set difference is asked between these two relationship of R and S, they said you should find a set difference of R and then S. So you see now, what you're going to do, you're going to like find a subtraction between then this one. So what is in here, you are going to less something that is not in here. So what you're going to do, you have your X, you have your Y, then this thing is here already, it's not here. So you have your A1, this is here, this is here. So you are going to take off each, and you have your B as 1, right? So there is nothing left to be subtract here from. So you are done with this. So whatever that is here, you take away what is here from this place. That is, in short, what they are saying. So if the reverse is the case, you have A's with a set difference of R. So what are you going to do? Can you try it? Okay. If you get it right, please let me know. So here, what is here and here? What is here that is here, so that you can be able to take that difference from this set or from this relation? So we know we are not dealing with this, rather we are dealing with this. So this is also present here. So you are going to take away this. But this, nothing exists from this R. Therefore, you are left with B and then 3. And this is the correct answer for this. Who get it right? So, and that is for how we deal with our relational algebra in database management system. And we are almost 40 minutes away from, or 30 minutes away from this class. So we have just a few minutes to go. So the next we are going to look at in a quicker note is entity relationship model. So what is entity relationship model? Entity relationship model is a graphical representation of our database. That's how well you can be able to identify entities are in your databases. So, and in doing that, we said entity relationship model has 3 basic components, and these components are entities, entities, attribute, and then the association. That is the relationship now. So, if we said entities, entities entity usually represented by a rectangle like this, and our attributes our attribute is represented by an oval like this one. And our relation, that is the association now, relationship, is represented by a decision we have as the word diamond shape, right? So this is the representation of this. And this entity that we are talking about here is being classified into, is being classified into what we call entity set and entity type. If we talk about the entity type. Entity type is the representation of a group or a set of an entities that is represented by what we call weak entity or strong entity. And this weak entity type is just those attributes or those entities without a primary key. A primary key is what we use to uniquely identify a record in our database. So if we talk about the strong entity type, those are entities with a primary key, right? Like a matrix number, order number, and what have you. So this entity set is a group entity with the same value, right? If you look at it very clearly from the previous classes, we have a tuples and an attribute like this one, where we say this is the entity set, right? And this, if probably we have a matrix number and what have you, this is entity type, right? This is entity type, this entity type, this entity type. But it depends this entity type whether it's a strong entity or a weak entity type. Are we together? So going forward, we have uh, something like if the key component we need to know in our entity relationship model. While doing this, we know we are going to have a simple attribute, we are going to have a composite attribute. That is, if you're talking about the attributes here, right? So the simple attribute, these are attributes that cannot be further be divided. If you have simple attribute, this attribute, it means they cannot go further. Like example, if you have age, can this age further be divided? But if you have a name, as what, as an attribute, which is going to be a composite attribute, this composite attribute can be able to be further classified or grouped into 2 or 3. We are where we have first name, second name, third name, and the rest. So if and only if we have identified an entity, this time around this entity is going to be a name or a student, please. Let's say student as an entity, and it's represented in form of a rectangle. And here we are going to identify the attributes of these students. We see we are going to have age, we are going to have name. Under this name, we can have first name, we can have what again? Second name or surname, we can have other name as well, other name. So, but here age is just like that. And then we can have maybe local government of origin, LGA, we have state, and what have you. So if something is given to you like this and said you should identify which one is a composite attribute and which one is a simple attribute, you can be able to identify on this very diagram, right? So, and with this, we have an insight of how these things, how we generate our attribute on this. So also we have what we call a key. So a key is usually used on a database in record, and this key are grouped into, we have almost one, we have primary key, which are used, is a single attribute that is uniquely used to identify record on your particular database. Two, we have composite key, and this composite key consists of 2 or more attributes, which is going to be used uniquely in order to identify these entities within your table. Example, we have probably employee ID and then department ID. So you see, these are very 2 key attributes that you can be able to use either of the 2 in order to perform to find out the record that exists on your database. So also we have candidate key, which usually is the combination of between 2 entity, or is a combination of an attribute that could be potentially serve as the primary key. Example, when we order a product online, so we see we are going to have a product, an order ID is going to serve as your primary key in order to identify the product you have purchased online. So the last one, we have a foreign key. This foreign key is going to establish the relationship between each of these tables, or between 2 more tables within your databases. So the most useful uh, keys here in database management system is 2. One is the primary key, which it must exist within a given table. 2 is the foreign key, which you are going to use in setting up the relationship amongst the tables that you are going to design in the database. So if we have something like this, uh, excuse me. So we are done with the entities. We don't have issue. We are done uh with the attributes. We don't have issue. So now is the relationship. That is the association. So, and sometimes this association, we call them cardinality ratio. So their duty or their work is just to show the relation, the linkage between each and every of the tables you are having in the database management system. So we in the types of the cardinality ratio we have here as one-to-one relationship. That is, if uh, certainly, let's say student and his course. So student can only take one BSc course at a time. So this is going to be one-to-one relationship. We have one-to-many relationship where student can take many courses within the department, right? And we also have many-to-one relationship where many students can take lectures from one lecturer, and we have many-to-many relationship where many lecturers can take many students in a given course. So each of these, the relationship that is going to have a linkage between these is going to be represented by what we call a verb, right? So example now, if we have, for instance, relationship between student as an entity with its own features or attributes, and we have courses as an entity again. So it's presented by this. So then the relationship here is going to be represented with a verb, and the verb here is going to be student enrolled course. So we are going to use enroll, right? Enroll for a course. So it depends. Is it one student? It depends on the peculiarity. If you're kind of a lesson teacher, you see now, many students can take one course, one student can take many courses. So it depends. So in this case, I would have liked to put it, many students can enroll into many courses to say. So this is the what? This is the association, and is represented with our diamond shape and with the actions of what you're going to do in this very particular relationship. So also we have what we call database normalization. So what is this database normalization? Database normalization is a process of uh, decomposing your table in a smaller unit. Is a process of normalizing or removing anomalies from your databases, and also is a process of eliminating redundant data. So, and we have the definition of a database normalization, and we have many forms of database normalization. We have first normal form, we have second normal form, we have third normal form, we have in some scholars you will see they have fourth, fifth, and the rest. But here we are going to discuss on the first normalization form, second normalization form, third normalization form, and Boyce Court normalization form. Before I give you a talk home exercise. So when we talked about the phase normalization from here, what they are saying is in essence to what have we have a rule for each normalization form in the first instance, and the rule of the first normalization form state that your table should contain a single value or should have an atomic value of an attribute or a column. So what they are saying here, you have a column like this, say this is a skills, this is a skills. So what they are saying, your column here should not have UI/X experience, JavaScript experience, design experience. No, it should have an atomic value of this column and attribute. Are we together? A single value of atomic. So that is the first rule. So whenever a database normalization is given to you or a table is given to you to normalize, you should first consider that each and every column has what we call a single atomic value into it. Then the second one is that the value stored in a column should be of the same domain. So you should not go and take your name here. You should not write name against skills. They should be values of the same domain. This is meant for skill, it should be for skills alone. So, and all columns in the table should have a unique name. You should not carry it out anyhow name that you can be able to use in the skills. Are we together? So, and again, the order in which you are going to store data, you must what? You must practice that in the first normalization form. So we have example is given and we had it on our slides. So we will not because we are having almost only 7 minutes to go. So we have second normalization form, and the second normalization form we said the first rule there state that it should first be in the first normalization form. So your table must first be in the first normalization form, and if you have it in the first normalization form, then the second one we have what we call, it should not have what we call partial dependencies. Partial dependencies is that here your when a table has a primary key that is made up of two or more columns, so and these column are not included with a primary key, so in such case the table is going to what depend solely on a primary key of another table. So your table should be able to avoid such scenario. So each table is expected to have their own primary key. So that is the second rule of the normalization form. And then we have the exercise, the examples given there. So then the third normalization form is that the first rule is that your table should be in the second normalization form, and the second rule is that dependencies. Transitive dependencies here, your primary key should not depend on another column rather than another primary key of another table, which is going to be your one, is going to be the association or the linkage between these two particular tables. So we have Boy's Court normal form, which is called BCNF. And in BCF, this is the higher version of the third normalization form. So it's an upgrade of the third normalization form. Most of the people, they stay or they stop at the third normalization form. This form deal with a certain types of anomalies that is not handled by what? By the third normalization form. So here, after your table is being in the first normalization form, so you should, as much as possible, try to have or to avoid multiple overlapping of a candidate key. We discussed about the candidate key in the previous slide. So you should be able, as much as possible, to avoid this overlapping of a candidate key. So they should not be, you have, be repeating in the normalization form. So we are going to take an exercise with this. We have come to the end of this class, and the exercise, the assignment or the exercise is going to be done in a week time. First, form any school management system, design the entity relationship diagram for it, and then try to normalize. On each table, state the normalization form you have taken part on that very tables. So thank you for being with us. Remain blessed.